Welcome to the video on the binomial distribution. So the binomial distribution is the probability distribution that shows the likelihood of an outcome given the probability of success and the number of trials. So you can only use this distribution when these four conditions are met. So there needs to be a fixed number of observations, which is going to be n. The observations have to be independent. So what you observed on one can't impact the other one. They need to be unrelated. Each observation has to have one of two outcomes. They have to be a success or a failure. And the probability of success cannot change with each trial. So here's our equation for our binomial distribution, where P is the probability of success, Q equals 1 minus P, which is the probability of failure, N is the number of trials, and X is the number of successes within N trials. So someone flips a coin 5 times. Consider getting heads a success. Draw the probability distribution. So P is our probability of success. So there's only 2 sides to a coin. So as long as it's an evenly weighted coin, you have a 50-50 chance for each one. So your probability of success will be 1/2 or 0.5. Q is your probability of failure. So it'll be 1 minus P, which is also 1/2 because you have a 50% chance of getting tails. N is your number of trials. In this case, we're flipping the coin 5 times, so it'll be 5. And then X is going to be the number of successes within N trials. So X is going to be everything from 0 to 5 because we could get heads 0 times, 1, 2, 3, 4, or 5 times. So we'll start with X being 0. So P0 equals N choose X. So 5C0. P is 1/2. X is 0. And then we'll do the Q, the probability of failure, to the N minus X. So 5 minus 0. So this would be 5. 5 choose 0 is 1. 1/2 to the 0 is 1. And 1/2 to the 5th would be 1/32. So the probability of 0 is 1 out of 32, which is approximately 0.031. Our probability of 1 is 5 choose 1 times 1/2 to the 1, and then 1/2 to the 4. So these exponents will add to 5 every time. So 5 choose 1 is 5. 1/2 to the first is 1/2. And then 1/2 to the 4th is 1/16. So this would equal 5/32, which is approximately 0.156. We'll do that same thing for P2, P3, P4, and P5. We'll have 5 choose 2 times 1/2 squared times 1/2 cubed, which is 10 times 1/4 times 1/8, which is 10/32, which equals 5/16, which is approximately 0.313. P3 is 5 choose 3 times 1/2 cubed times 1/2 squared, which is 10 times 1/8 times 1/4, which is also 10/32, which is 5/16, which is approximately 0.313. P4 is going to be the same as P1, and P5 will be the same as P0, and that's because our success and failure have the same probabilities. So P1 is approximately 0.156, which is equal to P4. P0 is approximately P5, which is 0.031. So if we were to draw that, our highest probability is 0.313. So this only needs to go up to like 0.4. And then our number of successes goes from 0 all the way to 5. So for 0, the probability was 0.031. So that'll be about there. For 1, it's 0.156. For 2, it was 0.313. For 3, it's that same thing. For 4, it was 0.156. And finally, for 5, it was 0.031. So this is your binomial distribution graph for this example. Next, we have how to calculate the mean and variance. The mean is the number of trials multiplied by the probability of success. So our mean for our previous one would be our number of trials, which is 5, times our probability of success, which was 0.5. So that would equal 2.5. Our variance is the number of trials multiplied by the probability of success and the probability of failure. So for our previous problem, it would be 5 times 0.5 times 0.5, which gives you 1.25. So your mean would be 2.5 and your variance would be 1.25. So next we'll learn how to calculate our binomial probabilities using our calculator. So to find the probability of exactly a certain number of successes, you'll click second vars, which is distribution, and then scroll down to binom PDF. When you hit enter, this is the screen that will appear. So you'll enter your trials, which is n. So our previous one, we had 5 trials. Your probability of success, p, you'll enter as a decimal or as a fraction, and it'll turn it into a decimal. So this is 0.5, and then your number of successes, x. So if we wanted to know the probability of 2 successes, we could put 2 there. And then you'll hit enter, and then this is what will show up on your screen. So your binomial PDF for 5 trials with a 0.5 chance of success, the probability of having 2 successes would be 0.3125. So that's how you would use your calculator for this. So now we have our first IB practice question where the calculator is allowed. It says there's a 15% chance that a dog is allergic to chicken. In a sample size of 35 dogs, A, what's the probability that 20 are allergic to chicken? So our probability of success, P, is 0.15, assuming success is that they're allergic to chicken. So our probability of failure, Q, is going to be 1 minus that. So that would be 0.85. Our number of trials, N, is 35, because our sample size is 35. And for A, we want the probability that 20 are allergic to it. So this time, X will be 20. So we could use our equation and do N choose X times the probability of success to the number of times we're having success times the probability of failure to our total minus the number of success, so the number of times we have failure. So this would be one way to do it, or we could just use our calculator and use our binomial PDF where our number of trials is 35, our probability of success is 0.15, and our number of successes is 20. So both of these ways would give you your answer of 9.43 times 10 to the negative 9. So this is a really small number, so it's approximately 0. So the probability that 20 are allergic to chicken is approximately 0. So the probability of all of them being allergic to chicken would also be approximately 0. If you wanted to know the probability of none of them being allergic to chicken, you could do your binomial PDF where it's 35.15 and none allergic to chicken, and that would be 0.0034. So even that's a very small number. So part C says find the mean and variance for this data. So our mean is equal to N times P. So there's 35 times our probability, which is 0.15. So our mean would be 5.25. So the average number of dogs, or the expected number of dogs that will be allergic to chicken in the sample size would be 5 or 6. So mean equals 5.25 dogs. And we could label all of these dogs. Now we just need to find our variance. which is n times p times q, which is 35 times 0.15 times 0.85, which gives us 4.4625. So our variance is approximately 4.46 dogs. So there are your answers to this question. Here we have our second practice question. It says Lucy is competing in a series of basketball games. Each game she has a 40% chance of winning. She is going to play 10 games. A, find the expected number of games that Lucy will lose. So we want to know how many she'll lose, and the probability of her losing is 60%, because she's going to win 40%, so if she's not winning, she has to lose, because there aren't going to be any tie games. So to find that expected number, it's going to be equal to our mean, which is our number times our probability. So that would be 10 times 0.6, so she's expected to lose 6 games. Part B says, what's the probability that Lucy wins all of her games? So because we have our calculator, we can use our binomial PDF. The number of trials is 10. The probability of winning is 40%, so 0.4. And we want to know the probability of winning all the games, so all 10. So if we enter that into our calculator, we'll get 1.05 times 10 to the negative 4. So that's 0.0001. So the probability she wins all her games is 0.001. So in summary, the binomial distribution is a probability distribution that shows the likelihood of an outcome given the probability of success and the number of trials. It can only be used when the following conditions are met. There is a fixed number of observations. The observations are independent. Each observation is one of 2 outcomes, success or failure, and the probability of success does not change. To calculate your probability, you would use this equation, where P is the probability of success, Q is the probability of failure, N is the number of trials, and X is the number of successes. The mean is the number of trials multiplied by the probability of success, and the variance is the number of trials multiplied by the probability of success and failure. That's all for this video. Thank you for watching.